Oi, minasan, konnichiwa, Zamurai Engineer desu. So, let us start today's live stream lecture on our steel design continuation on block shear. Before that, let us verify if our sound is clear. Please confirm. Okay. Thank you for confirmation. So, shout out to Mark Anthony for confirmation. Let us start. Okay, so last meeting we already have discussed the tension member, several major topic on tension member. So we have topic like those theory on yield, rupture, block shear, and bearing bolt holes, or bearing at bolt holes. So bearing stress, block stress, rupture, and yield. So those are the four different major topics on tension members, and they are the what we call the strength design. Okay, strength design. So we already discussed the manual, meaning what are the references of those topics. Yield from the code perspective, meaning AISC 360-16. Rupture from the perspective of code, block shear, bearing, and also up to the design aids. Okay, so very important, we have to aid our design by using those tools. And now we will complete the topic by discussing the block shear theory. Okay, how they started, how they think about it, and how the theory proceed up to the today's level of study. Okay, so and afterwards we will again continue with the bearing stress discussion on tension member and the same manner. I think we will cut between the discussion of these two main major topics, because we want to have our live stream video as short as possible, so that you can be encouraged to rewatch and review, and also it would be easier for you to take a look at those topics. Okay. So let us proceed. In your screen, you have the block shear. Okay. So I don't want to forget. That's why I use I use the logo of AISC so that we can show courtesy, because this material is promoted and made by AISC through the efforts of Dr. Sibian of University of Massachusetts Amherst. Anyway, we are live from Taguig City. So this is your professor, Dr. AP Zantua. So block shear. Okay, I think I have a little bit of technical problem. Anyway, let's have this topic. So in a similar fashion, let us present this topic, block shear. This is theory. So we already talked about the block shear from the code perspective. We are now going to take this theory. Failure tears out block of steel. Okay? So usually the failure is not, or sometimes the failure is not on the very ideal way, wherein it is failing on the transverse axis. So the elements not failing on transverse axis, but rather, for example, staggered, okay, on the staggered plane, and sometimes on block shear plane. So this is what we know of. Block defined by center lines of poles. So we will go through the center line of holes as we can to model out the shearing failure of the element. Okay, and also it is defined by edge of welds. So meaning to say there are two major types of connection, either it is bolt or weld. So in each of this connection, we have to define it by this. Take a look, center line, but when we are talking of weld or welding connection, the damage would be on the edge of the welding, not on the center line. Okay, so and it is quite logical. Okay, it's quite logical, as you can imagine, because the center line of bolts is the weakest line. Okay, the weakest failure line, and the same manner as the edge of the weld. So what we are really talking about is the weakest link principle. Okay? The state of combined yielding and rupture. This is a combination, okay, of yielding and rupture into one, and we call it simply block shear. So that's why this is the third topic. We we talk about first yielding, second rupture. Now we have this block shear. Okay. So what we already learned from yielding and rupture. So yielding, we use the gross area. Rupture, we use the net area or the effective area. Okay. So failure planes, we have at least one, each in tension and shear. So that is the minimum because it is a block. So it could be what? It could be 90 degrees from one another. So all of these planes could describe a two-dimensional failure pattern. Okay. So typical example of this angle connected on one leg, we already showed you. Okay. And W-shaped flange connection and plate connection. So to give you a review of what we had last meeting, this is an angle or one leg connection. As you can see, the connection, the bolt would be placed on the holes. As you can see in the figure, there are 3 holes, and those 3 holes are aligned on one side of the leg. So one leg angle connected member. Okay. Also, while we are discussing, you can have your questions written on our live chat. And while we are doing that, our attendance checker could also try to have our attendance recorded during this discussion. So now, currently on your screen, we have the diagram representation of block shear on that one leg of the angular section. Okay, so on the top, that is the picture wherein the angle is being shown on the red. The bottom diagram, that is the plate wherein the angular member is attached. Okay, so as you can see, we have the tension force piece of bend, which is the nominal tension force. So now shear plane. So we have the shear plane like this, looking like this. This is the shear plane. Since this is a series of bolt, this is a shear plane through the center of the bolt. Okay, just because that is the weakest link. Okay, and then it may not push throughout because as you can see, this is a member. Okay, this is a member, and rather than the failure plane proceeding longitudinally throughout, it will just proceed up to the last bolt hole and just proceed 90 degrees on either side, most probably on this side without the leg, okay? Because this is the weaker side compared to the other side. It is a stronger side because it has more area due to the leg, the presence of the leg. Okay? So it is in most probability it would fail like this. So now we can define that this type of failure is defined by two types of stress, shear and this one, the tension plane. So shear plane and tension plane. So there are two types. So yielding and rupture. So yielding and rupture. So we have what we call, this is a block failure, block shear. So meaning to say this would be detached. This would be detached, and this red angular member would become two pieces. So this is one piece and the other one's this one. So they will be separated from one another, and therefore the connection would fail. Okay? And the lower part, the plate could also be failing in a similar manner, like this. Okay, similar. So block shear failure plane, including both the tension, this is the tension plane, and the shear plane. Okay, so next, can we take this off first? Okay, so on your screen right now, so this is what happened. Okay, so what I'm describing is happened on the upper portion of the diagram, and also when the plate fail, this is what happened. So this on the upper side, this is what will happen when the angular element would fail. This is what happened when the plate would fail. So as you can see on the label, block failure from angle. Angle meaning angular element, angular section. So this is an angular section, as you can see on the drawing. This is how you draw the angular section. Okay, and then this is a plate. So block failure from plate. Okay, so this is the way it could fail on the attached element, and this is the way it could fail on the elements wherein the angle is attached. So there are two cases, possible cases. Either way, they are called block shear failure. So let's go to the next. So we have the W shape. Okay, instead of angular section, we have the W shape, and we are looking at, this is the flange. This is the flange with two longitudinal series of bolt holes. Okay, so flange. This is one flange. Okay, and this broken lines show us the location of the web. This is the web location. So therefore, the bolt holes are located on either side of the web. Okay, on the either side of the flange with respect to the web. Okay, so if you can recall the angular block shear that we just explained, it could happen also when we are using W-shaped section. Okay, so it would fail in this manner. Okay, so one block shear here and another block shear there. Okay, it's very hard to fail in this manner on the transverse axis due to the presence of another flange on the opposite side and also the presence of web. Okay, so it's more logical to think that this type of failure has more likelihood of happening rather than the transverse failure. Okay? So the failure would look like this. Okay, so it's very clear right now. This is what was left on the tension member, since it is what being pulled in this direction. So these two parts would also fall down due to gravity. Okay? So failure in that particular shape. Okay? What happens on the plate? Okay, what happens on the plate? So taking a look at the red portion, what happens on the plate? If ever the plate is the weaker side compared to the W section, so they will not happen simultaneously. It is very unlikely. I cannot say they will not happen simultaneously actually, but it is very unlikely. The likelihood of happening is very low. Okay, very low likelihood. So it would happen either way. It could happen, the failure could happen on the element, on the attached element, and or it could happen on the plate wherein the element is attached. So right now we are looking at this. So since this is W section, there are two possibilities of happening. So one and this one, they are a pair blocks here, just like what will happen on the W section, and another type of block shear here. Okay, a single block, okay, that looks like this, looks like U-shaped failure. Okay, this is the possibility. So when we are dealing with angular section attached to a plate, there are two possibilities. But when we are dealing with W section, there are three possibilities of failure. Okay, one for the W section, and two possibilities when we are looking at the plate like this. Okay, hello, very clear right now the three possibilities of block shear failure. Okay, what about when the element is welded rather than bolted? Okay, so the gray portion here, this going here and going there, that is the welded portion. That is the welded portion. Weld around the perimeter. Okay, what would happen? So let's take a look on the possibility. So it could fail on this manner. It is welded there, welded there, but it could fail rather than failing up to this point. It would just fail directly here. Okay, so it would just fail directly here. So there is a what? There is a failure section here. It's not following the welded line, okay? Welded edge line. So we are following the edge of the weld here, edge, but now it did not follow the weld here, but it go through the shortest distance. This is the shortest distance of failure rather than going here and failing here. No? So it is one block. Okay? Another possibility, let us first come up with so there the welding is located here from this point, starting here, going down here and going up here. So this is the end point of welding that actually corresponds to this point. So there is no welding here. There's no welding up to this point, so it may break down on this portion and just break down like this as a block. Okay, so again you can review it right here. So the failure could be up to this point or up to this point. This is the edge, like this. So the failure could be like this, and the failure could be like this. Okay, so there are two ways that it could fail. Okay, so therefore this is what it looks like. Plate failure, two ways, two possibilities failing. Okay, so those are the concept wherein a member attached to another member could fail by block shear failure. Okay, any question about this? This is the theory, the thinking coming out from the perspective of studies documented and put into principles and concept. So they observe those type of failures, they observe those failed elements, and they think of a way how to explain it. Okay, so that's how we engineers do it. We think of the theory, physics, physical theory, engineering concept, and connect those into a logical set of explanation in order to support our thinking how really the element failed. Okay? So due to series of study of observation, so That's all about the theory, and we have to stop this live stream right here when I see there are no questions. So we will just return back on the live stream for the next topic. Okay. So again, this Professor Dr. AP, Preaching Engineering for Nation.